and your battery died. But have you ever wondered what's actually happening inside this battery?
So, what is battery? We have got different types of batteries nowadays. But one of the most common battery that we use every day is called a lithium-ion battery.
Attach the nail into the lemon. Then attach the copper wire into the other lemon. Repeat the steps for the 4 remaining lemons. Then connect the LED light. To our left, we have our anode, which is known as the negative terminal, and it is a carbon graphite. Graphite has a crystal structure of loosely bonded layers to allow lithium to be wedged easily in between. And on our right, we have our cathode, which is known as the positive terminal. It is made out of lithium metal oxide. It is connected to an external load to allow electrons to flow through. And in the middle, we have our electrolyte, which acts as a guard to allow lithium ions to move without letting the electrons through. Lithium atom has 3 electrons. It is highly reactive as it wants to give out its outermost electrons. It has high electropositivity, which means it has a higher tendency to lose electrons. Lithium atom loses 1 electron and turns into a positively charged lithium ion. The electrons travel through the load from the anode to the cathode. At the same time, lithium ions travels through the electrolyte and wedges itself in the cathode. And this is our discharging process. When almost all of the lithium has left the graphite layer and joined the cathode, our battery is now running empty. And so we charge our devices by plugging it into a power source. The power source applies a higher force on the flow of electrons in the opposite directions. Electrons are pulled away from the cathode. And at the same time, lithium is also pulled through the electrolyte and back into the layers of graphite. This is an unstable state. As soon as the power source is removed and the load is connected, the same thing repeats again.
However, there are also some things that we have to take note of. The cathode and the anode cannot touch. One example of this is when internal temperature rises. This causes the electrolyte to dry up. Hence, we place a separator in the middle. Second,
lithium cobalt oxide and graphite are not good at collecting and distributing electrons. Therefore, we place a conductive copper layer to the graphite and another conductive aluminum layer to the lithium cobalt oxide.
And these sheets are called collectors. Solvent molecules in the electrolyte covers the lithium ion when they reach the graphite. The lithium ion, solvent molecules, and the graphite reacts to form an SEI layer, known as solid electrolyte interface. This SEI layer prevents the direct contact of electrons and electrolytes, thus preventing the electrolytes from degradation. While the SEI layer prevents the degradation of electrolyte, it also consumes lithium irreversibly, and so reducing the overall quantity of lithium. Second, when our battery is fully discharged, there will be too much lithium left in the cobalt side. This causes an irreversible lithium oxide and cobalt-2 oxide.
From lemon to lithium, that's the power of science.